So we're going to talk a little bit about triangle congruency. Now, this is something that firmly belongs in the realm of geometry. However, in the DPS integrated curriculum, it will show up in integrated 1, which is why I would like to talk about it briefly. Now, please remember that congruency, or something, when things are congruent, that means they are the same size, same shape. So we're talking about triangles that are exactly the same size, same shape. They may have different orientation, but same size, same shape. Now, for things to be the same size, same shape, that means all the side lengths are equal and all of the angles are also equal. Now, if you have to prove that two triangles are congruent, it's going to take a long time to do that if you have to find every side length and every angle to prove that they're congruent. So there are some shortcuts that we can use to prove that triangles are congruent. And these shortcuts have 3-letter names. And remember, there is no ass in geometry. All right. So let's say we have two triangles, and we think they're congruent. They look congruent, but we're not sure. Now, if a triangle has two pairs of congruent sides, so in other words, this side here is congruent to this side here, and this right side is congruent to this right side, and the angle that is adjacent to both side lengths happens to be congruent, we can say that you have two congruent triangles. And the congruency theorem that would cover this situation would be referred to as side angle side congruency. Because you have a side, an adjacent angle, and then another adjacent side that you know are congruent, therefore the whole triangle will be congruent. Now, if the whole triangle is going to be congruent, that would also mean that the other pieces of the triangle that are not talked about would be congruent to each other. So in other words, this is going to be congruent to this side, this angle, and this angle, and this angle. And we know that because congruent parts of, not congruent parts, corresponding parts of congruent triangles are congruent. CPCTC will allow us to say that all pieces of the triangles are congruent. All right, that's a little bonus there. CPCTC. All right, so the next theorem that we're going to talk about is if we have all three side lengths are congruent, then we can say the whole triangle is going to be congruent, and that is called side, side, side congruency. Side, side, side congruency. And then from there you can show that all the angles are equal using CPCTC. Next up, if you have an angle, an adjacent side, and then the adjacent angle, you have angle, side, angle congruency. Finally, we also have angle, angle, side. So angle, angle, side. Also, you could say side, angle, angle, same thing. Congruency is the fourth. Now, the one that you cannot use, and that you're really tempted to, is to say angle, side, side. But remember, there's no ass in geometry. This one will not work, so don't try it. All right, so let's use our angle congruencies. And let's say in a problem they tell us, they give you this drawing. Notice these two lines are parallel, and they give you that these two side lengths are congruent. Now, obviously, it doesn't look that way. This is not to scale. Move on. Do we have enough information to say that these two triangles are congruent? Well, let's label them. This is point A, this is point B, point C, point D, and let's go with point E. So can we say that these are congruent triangles? Well, right now, from what we see, we only have a pair of congruent sides. But wait! We have two parallel lines and we have transversals. We have some transversals rules that we can use, right? So we know that this angle here is congruent to this angle here. So angle ACB is congruent to angle DCE because they are vertical angles. All right. So what other angle do we need, or side? Well, we're just going to be tough to get a side line. But what other angle do we need to prove that these two triangles are congruent? Well, we have an angle and a side, so we need one of the two other angles. Either one would work. So let's go ahead and use this one. This angle is congruent to this angle because, and so let's write that down. Angle BAC is congruent to angle CED because they are alternate interior angles. And now I've set up a situation where I have angle, side. Congruency. Now I could have done it a different way, of course. And I could have said that this angle here, I wanted orange. This angle here is congruent to this angle here, also using alternate interior angles, and then that way I would have angle, side, angle. Congruency, and that would work as well. All right, so that is what I have for you in triangle congruencies. There is one more dealing with right angles, which I'm not going to get into right now. All right.